So okay, last time, if I remember correctly, we stopped on the ranges, right? For regular expressions.
I think yes.
Okay, so let's just continue. And today we'll kind of finish the regular expressions topic in Python. And yeah, let me just find it. So yeah, let's create a new folder as always. So, and before we saw like ranges, and now I want like to show you how you can like specify, for example, the negative pattern. That means that you will match some characters which are like outside of the scope that you specified. So if you have a file, let's call it negative sets.py. Yeah, and we need like to import a regular expression module in Python. And let's create a couple like patterns. For example, P1 as a pattern where we want to find all non-vowel symbols. For example, we need like to specify all vowel symbols in the brackets. And here, so we use like a caret symbol before all our characters, letters, and then that means that so this pattern will be matching everything which is like not A, E, I, O, U. Also, for example, we can like specify a pattern which will find everything which is not a digit, and in this case we need like to specify the range of the digits. Here I specified like from 0 to 9, and let's create just like some words that we will use for our regular expression search. So it can be A, B, C, Y, then like let's do E, O, and some numbers, for example 3, 5. And now let's just go through the pattern. Oh no, let's go through the words. For W in words, we will test like each of our regular expression pattern, so P1 and P2, for current words. So in here I just want to check the result, which is like result is like we will convert it to Boolean data type to have like a true false, either we matched to the pattern or not. And here we need like just to provide research P1 W, and then let's call it like result 1 and result 2. Result 2 will be the same but with a P2. And then now let's just format the output. So for example, P1 in word. And then we want to put res1 here. Oops. And now P2 in word res2. Let's just run it. So when we can see, and let's just like add one extra new line symbol to separate different words. So here we have that the A, that means so is this pattern matches A, and it doesn't, because we specified that we want like to exclude A from our pattern, right, by using this syntax. And then so does this pattern match? Yes, because so this is everything but not numbers, and then it means that a is not a number, and because of that we have true. And simply it's like for all other like cases. So you can see if we have like a vowel symbol, we skip it, and yeah, so basically that's it. And for example, for numbers, we will exclude them from the search. I mean, like, we will not find our pattern inside of the number because we just like simply specified p2 as a something which is not a number. And now let's switch to the quantifiers. So if you have any questions, yeah, just like let me know about the negative.
If I understand correctly, just using the symbol tab, it's allow us to use negative regular expression, yes?
Yeah. So it means that, for example, sometimes you want like to find everything which is not a number inside of your string, and then yeah, you can like put a caret symbol. So you can like specify like a kind of as a set of values that you want like to omit, and then like yeah, inside of the square brackets you need like in the beginning put the caret symbol, and then after that specify what you want like to exclude from the search. And yeah, basically that's it.
Okay, thank you.
Yeah, let's now switch to the quantifiers, because for now we just like worked mostly with a single entry. I mean, like, for example, if we had like a pattern, then we matched it to something, and it was like usually like a unique entry. But now we will like find out how to, for example, specify a more generic patterns which can capture like a huge amount of substring inside of the original string. And let's start from the, I'll call it like asterisk dot py. So yeah, let me just show you. So there are like a lot of different like ways to specify quantifiers in the regular expressions. And basically, so the syntax in Python that we can utilize is the following one. So we have like a asterisk symbol, which means that if we have something before the asterisk symbol, we will try to match 0 occurrences of this like thing or any number of it. So for plus, we want like to have at least one like match of the specified like sequence. I mean, probably it's gonna be easier when we will see the examples, but this is just like as a brief overview that there are like different ways how you can like specify quantifiers, and now we will like just go one by one through the different quantifiers that are like persist in the regular expressions. And let's start from the asterisk quantifier. And so basically it means that we will match any number of occurrences of the preceding element. And let's, for example, start with a pattern. I will specify pattern as a CA like a star T. And then, for example, we have our words. So words could be CT, cat, CAAT, CAAT, something like that. And basically, so for all these cases, this pattern will give us a match, because A star means so that we want like to have 0A, I mean like number of times when like A appeared in the string could be like 0, 1, 2, and as many as you want. And basically for all these cases, it's supposed to give us like a true result. But if we start, for example, from another like letter, bad, And then in this case, C doesn't match to the B, and because of that, it's gonna give us false. Let's just go through each word and just simply print the result so that the P in work in the same way. And then I want just like to get the result boolean of the, yeah, we need like to import the regular expression module. So in here we have research, and then we need like to specify pattern and our word. Okay, and now let's just run it. And you can see so that the cat, our pattern cat in CT, it's true. Then cat in cat is true. And basically for all these cases it's true, but then it's false. Yeah, and so also as another example that can be utilized, I just want to show you. So for example, sometimes when I work with titles of the gene expression datasets, as you might already saw, in this case you will have that the words are like, for example, they start usually.
Can I ask you why the first CT is true?
Yeah, because so the star means that it can be, so the preceded element, in our case it's like A, right? So A is like element to which we apply a quantifier, and star corresponds to either like anything which is like greater or equal to 0 occurrences. And because of that, so it could be that you even don't have like A in the string, right? And so the next one which we will see is like a plus quantifier, and in this case it's like basically the same idea is the same. So if we have like quantifier plus, in this case we will have like greater or equal than 1 occurrences, and in this case, so we can try it like in the same way. In reality, we can like right away check it here. So for example, let's say that we have P1 is a, here we use like a star symbol, and P2 is a CA plus T. And now let's just print how this quantifier works. And also I'll again put a new line symbol just like to separate our results. So and you can see in the first case, if you have like a plus, that means like at least one A should be in the matched string. And since we don't have it, we will have false. But star, yeah, it's more flexible. It even like allows you to have like 0 occurrences. Yeah.
I understand now. Thank you.
Yeah, welcome, welcome. So I just wanted to show you that, for example, sometimes you want like to find some specific substring in the elements that you have, and just like as an example, I want to show you particular case when we like, for example, working with the IDs of the gene expression datasets. So for each gene expression dataset in NCBI database, gene expression omnibus, we have like a ID, and we can like put some random here. So for example, GSE 100, and then also GSE 53986, something like that. And then you want, for example, specify a pattern which will find you just like sequence of the numbers or sequence of the digits. And in this case, your pattern could be like R, and you need like to specify the range of numbers. So it's like from 8 to 9, and then you can say that I want like to have as many as possible numbers from our string, right? Or you can like use plus also. And let's just for each word in words, let's do something similar. So this is will gonna give us like just as a Boolean result, either it's true or false. So let's execute it. So basically it's true, but also you can check what was like matched there, right? You can just like print the res itself, and you can see so that the match inside of the first word is 100, and in the next one is like 500, I mean like 53968. So basically it's like as a way how you can, for example, find particular things in the like strings, which usually sometimes you need to have in the code. Okay, that was like about the asterisk, and about the plus we already saw. Yeah. And there is like another one which is like the question mark. I'll create another file. And again, we want like to import the regular expressions. And now you can have a pattern which is a CA question mark T. Here we want like to put that our string is raw and words are the same. So let's just use the same words. And basically the idea of the question mark quantifier, it means like 0 or 1, like number of occurrences. And then so for word in words, let's just print word and then the result. So it's research pattern word, and I want like to execute this. So as you can see, for the CT we have like a true result. There is like match which is CT, and cat we also have a true result, but for CAAT it's none, and if we try to convert it to the Boolean data type it will give us like false, and for bet it's also false because it doesn't start from the C letter. So this is about the question mark, and now like I want to show you exact quantifiers when you need like, to specify exact number of how many times your pattern matches. So it's the exact quantifiers.py. And in this case, let's take a look on the following example. I'll just copy and paste it. So here we have like a pattern which is like CA, and now we want like to have A 2 times. And to do that, you can specify number of occurrences that you want like to have by using the curly brackets, and we specified number here. And then so basically, as you can imagine, we will just match, we will have a match for the CAAT. So yeah, you can see that we have match just like for CAAT and not for any other. And in reality, you can specify the range for the quantifier. For example, if you want like to have from 2 to 3, right? In this case, you need like to just put them through the I forgot. Okay, I mean, like, you just like need to put them right away, like 2, 3, and it's gonna work. So let's just add one extra new line. So you can see so that the CAAT is true and C with triple A also true. Okay, yeah, so comma symbol, yeah, sometimes I'm just very interesting. Yeah, and also there is like you can specify just like the lower bound, upper bound by using the following syntax. Let's just again copy and paste it. Yeah, so here we have like pattern for 2 or more A's in our pattern, and to specify 2 and more, so you just need like to put comma symbol, and you don't need like to specify anything as a upper bound. And in this case, it's going to be anything which starts from 2 and up to arbitrary number. So basically, it's like if you, for example, put 1 comma, then it's like the same as a plus, right? But sometimes, for example, you need like to have more than 1, and you can like specify it in this way. And then also you can specify that I want like to have up to some value. For example, like 0, 1, 2. So guys, is it like clear?
Yes. Now it's clear.
Okay, cool. Now I want like to show you about also it's like related to the quantifiers, and there is a thing about how the quantifiers work in terms of the how many characters symbols they will contain in the end, the matched result will contain. So let's create a new file. I'll call it like greedy non-greedy.py. And in reality, so we have like by default the pattern with quantifier works in a greedy mode. I'll just copy and paste the example. So here we have like a text, and guys, so question to you. So do you know, have you ever seen this type of the text files?
I think no.
No? Okay, let me then just show you as an example. So if we open our browser and then let's go to, like, for example, google.com, and in reality, so basically this is a page, and the like a file format that used for this page is HTML, and probably even we can like take a look on some elements. Yeah, and you can see so basically how it starts. You have this this type of brackets, and then you have like some text inside of them. And in reality, this example that we have here, you can think about it as a HTML. So basically, this is like specifying some type of the object in the HTML, and usually you have like the opening of the like a block of the element, and then this means that you closed it. And for example, here we have that this is a like a body of our HTML, and also you can find particular element. So I don't know, for example, this like button store, and you can see so that you have like a particular tag. So that this means that this is like a tag, and then you have like specific class. This like specifies what kind of styles are like applied to this button. But I mean, like, the idea is that it's like HTML. So you have like a opened tag, and then you close this tag by using this syntax with a slash symbol. And this is just like as a substring from the huge HTML. And here we just have like, for example, the greedy pattern. That means that we have like open bracket, and then we want like to find anything. So dot, as you remember, this meta character means like any symbol, so anything can be here. And then like the star quantifier means that like any number of occurrences is allowed to any symbol. And then here we have like just like we closed the bracket. And if we have this particular pattern, by default it works in a greedy mode. That means that we start like matching to the string that we have. So we start from the open bracket, right? And this part, like we have a match, right? And then anything, like any symbol, can be repeated as many times as you want. So, and basically the whole field part, this one, can be matched to our pattern. And then we just have the closed bracket. But you can say that I want like to have it in non-greedy mode. And in this case, you will just find this particular part, because this is the first time when you closed the bracket. And as you can see, so in the end of our pattern, we have the closed bracket. And let's just run it. So, and you can see that that in the first result we got the whole text line that we had in the beginning. But in the non-greedy match, we just found the first div inside of our string. So, and this is just like a very useful thing, because sometimes you don't need like to find the whole thing. You sometimes need like to focus on a smaller part, and just like as a note that by default pattern works in a greedy mode, but you can change it. So in this case, you put the question mark right after the quantifier, I mean like after the star quantifier, and then it will work in non-greedy mode. Now let's switch to the groups. We can specify groups inside of our patterns. And so why it's needed, sometimes you want like to, for example, you have like a string, right? And you want like to find different substrings at once. And then you can specify groups inside of your pattern. You can say that this is a group 1, this is a group 2, and I want like to find simultaneously group 1, group 2, and then have access to this like matched result in the result of the search. And I just like want to show you how it looks like. So there is like some explanation that you can just take a look. Maybe it can help you like to visualize the idea. But in reality, so here we have like a pattern, and to say that this is a group of characters or like a group of symbols, you need like to put them in the like a regular type of brackets, and then it will like during the regular expression search, it will, so we will assume that this is a group. For example, if we have just like a cat, we have just like one group, which is not very meaningful, so it's like not interesting. But in reality, so you can specify several groups. For example, here we have like, you can see that this is the first group, this is the second group, and this is the third group. So for each group, to specify it, you just need like to put it in the regular brackets. And yeah, and then so after we got the search result, we will have all groups in our result. So let's just copy and paste this example. I'll create a new file. And why it's like useful, sometimes you can utilize it, for example, to find particular things in a structured type of data. Here we have like just text. You can think about it as a, I don't know, let's say that this is a representation of the social security number. We can like just imagine that this is a social security number, and we want like to get first three numbers, then we know that there is a dash symbol, and then we want like to catch next two symbols, and basically we will encapsulate first three symbols into group, then like next two numbers, two digits, we will also put them in a group. So let's just run it. I will comment this part for beginning. Let's print the res without any extra formatting. So, and you can see so that the whole match is like our full string, right? But also you can print the res groups. And you can see, so now you have the groups that you found. And basically this is the first group, right? This is the second group. And this is the third group, which is like very intuitive. So you have like the day starts from 1, 2, 3. But in reality, there is like also the zero group, which is like the whole match. Because you can see, so our pattern matches fully to the text that we had, right? Because so the format as it's like specified, we have like 3 digits, then we have like dash, then 2 digits, dash, and 4 digits. And basically because of that, it like matches to the whole thing too. But then you can get the particular part of your result. For example, if you need like just to work with the group, so in this case, let's execute it. Not groups, but group. So if you want like to get a particular group, you can just like specify the the number. So here we got like just 27. And then, for example, you can, I don't know, perform any operations that you need to perform. For example, you can like just merge it and like omit all dashes. Or, for example, sometimes you want to have, let's say that you want to like format the documents, right? And usually you don't want like to show the whole number in the document. So I don't know, have you seen it? So for example, if you're like working with the debit cards, credit cards, in the documents that they sometimes send you, they just like highlights you last 4 numbers. So have you seen it? Yes.
Yes.
Okay, so yeah, and let's just try to mimic this example. So we can say that, okay, we have, for example, like 3 stars, then like 2 stars, and in the end I want like just to put res group 3, and I want to print it. So yeah, and this is just as an example, so that you can like just get particular part of your text that you had and somehow reformat it. Yeah, also you can like give a name for your group. I don't know, to be honest, I usually don't use it like in real programs that I write, but I believe someone needs it, so it can like make it more clear. You can like give a name for each group. So here we had like just we could like use indexing for each group, right? Yeah, also I wanted to show you that the print res group 0 should give us the full result, just like that. You can like also provide 0 as a group, because the whole pattern itself considered as a 0 group. Yeah, and now I want like to show you about named groups. So I'll just comment this part. And
I want to ask you about the groups and group option.
yeah.
It is from regular expression packages, or it is the option from print command?
So groups, it's like from the regular expression, because research, it gives us as a result the object from the, I mean, like it's a regular expression object, so we can check that the print res, print type of res. Let's just run it. So you see that it's a particular type of object. It's like an object from the like a regular expression match. Yeah, and then so there is a trick that you can like even check what kind of the possible methods and attributes inside of the object. There is a function which is called like dir. You can provide the res here, and let's just run it. So, and this gives us like all possible things that we can utilize with our object. So, and you can see so that inside of this object we have like a method group, we have method groups. Also, there is like a method span, begin, end, which we saw before. Start, end. Yeah.
Okay, thank you.
Yeah, welcome. And about naming. So here you can like specify the name, and the syntax is like the following one. So inside of the brackets, we need like to start from the question mark P, then you specify the name for this particular group, right? And then this is basically the same thing that we had before. And in this case, you can see that we had like a date as our text, and now we just like get the match result by searching our pattern in the text, and then you can get the group by using the name of this group instead of the index, which is like another possible way. But for example, just like from my point of view, I usually not like specifying a very huge insane patterns, and I usually can remember which index is like for example important for me. But probably if you have like something insanely huge, or you don't want to mess up, you can specify a name, and then it's like just much easier that you know that you assume that the first 4 digits are the year, right? And then you can just like say that, okay, I need a group which is like year, not like a number, which is more explicit thing. Yeah, let's just run it to verify that it works properly. So yeah, so as you can see, we matched the year from our whole string. Then we also found the months and the day. Yeah. And then you can like work around it in your programs. Also, there is like a very interesting thing. I mean, like sometimes it's very useful, which is like non-capturing groups. Again, I will comment this part. Sometimes you want to say that, for example, there is a group that I want to match, but before it or like later on, there could be like some text which I want like to avoid, but it should be there too. And here, just like as an example, like a toy example. So here, for example, right, that we had text, and text you can see, so it starts from red apple, green apple, yellow apple, and then in our pattern we're saying that this is a group that we want like just have, but not to capture it. And to specify it, you need like to put like a question mark and then column symbol. Yeah, and as you can see, so here we use like instead of search, we use find iter method. But basically it's like very similar. But instead of the single match object, it gives us like multiple of them, because we are like saying that there could be multiple entrances inside of the text that we are searching. So here you can see that we got like the first apple, which starts from the position 0 to 8. So the match is like red apple, but the group that we captured is just apple. Then also from 9 to 19, and the match object is a green apple, but also we have like just a group that we can then get. It's like apple, again apple, yeah. So yeah, and find iter, as I said, so it's like if you need like to get all matches, not just like single one, because if you had like if you had just like one match, so for example match, just like research pattern text and then print match, you can see that we found only the first entry of our pattern. But in find iter, you can like say that, okay, I want like to find everything. So this is about non-capturing groups. Yeah, there is a point about nested groups. I'll just like say to you that you can take a look on a web page. For me, it's like I mean, like, usually I'm not doing like some nested groups, but maybe if in your work you will like heavily, I mean, like, if you're gonna heavily work with the text and you need like to analyze it and to fetch some nested type of structures, then you can just like take a look that there is something which is called like nested groups, and you can utilize them in regular expressions. In my particular case, I usually like don't have any nested structures, so, and because of that I'm not sure that I want like to cover it right now. Also, you can utilize the back references in groups, which is very handy. Sometimes you can like even in the pattern you can say that I had like some particular group and I just want to put it one more time here, and don't specify the whole group again. So let's take a look on the example. I'll comment all this part. So here is our example. So we have the text, which is this is a test, and then our pattern. So like B, it means that we have a word boundary. That means that it's supposed to be a word, and word is like everything which contains like word type like symbols, not like spaces, not some like crazy symbols. And then we have that we want like to match one or more occurrences of any word character, right? Then S plus means like as many spaces can be there. I mean like anything which can be considered as a white space character. It's like just like regular white space, or like for example the tab symbol. So also considered as a white space between elements. And then here we specified the group. So that means that you can see this is our first group, right? Because it's like we go like from left to right, and this is the first time where we see regular type of brackets, and that means that we specified a group here. And then we can reutilize it. We can say that I want like to have here the same thing as the group 1. And basically in this case we don't need like to put the whole group one more time. I mean like I don't need like to type I need like to open brackets and then put like a /w plus. And sometimes your pattern can be very, I mean like your group can be very long, right? And you just need like to specify it once, and then you can reutilize it inside of the same pattern. And in this particular case, we can find duplicate words. So if we have that something is like repeated multiple times, 2 times, then we will find it. So you can see that we identified duplicate words because this word is like going 2 times, like is and then again is, and also test. And basically our pattern matches these occurrences. So for example, this is a is, and this is our first group because we said that we have a boundary word. Basically, this is a word, and then we had like any non-zero entry of the white spaces. So here we have like 1 white space, and then we put again like a first group, which is like the same word. So guys, did you follow?
Right. Yes, but here it's more difficult.
So yeah, I mean, like probably the best thing is like try to at some moment practice, and since you're like working with, I mean, like, since you're like in the system biology course, definitely you will faced with cases where you need like to utilize the regular expressions. And also in my mind, so it's like very, so it's frequently appearing in the web programming because with this like HTML and all other like data types that they have there and like file formats, sometimes it's like very important to find some things inside of the in the text there. And I mean, like, for example, when I'm like doing something related to web programming, from time to time I really need to have like a regular expression patterns there. And as an example, all of you like working with different websites right now, right? And from time to time there are like some forms that you need like to fill up. And for example, you see that when you try to put a word in the field which specifies the date of birth, right? If your date of birth is like just numbers, you cannot usually put the characters there. And basically how you can check it, you can specify the regular expression pattern and then try to identify. If user provided something which is not digits, then just like highlight a warning that person doing something wrong. And also with for example, when you have like a banking account tab, sometimes you're like specifying the number there, which is like binded to the account when you want like to log into to your like account. And then also usually it's like how it parses, I believe it's like utilizes the regular expression, because you know that usually it's like putting this like, for example, +7 by default for you, or also it can like format the result in more nice way, like to split the whole number by like some number of digits. Yeah. And also we can use substitutions with regular expressions. So I will call it like just sub.py. And this is an example. Yeah.
Can I ask you
Yeah.
some questions? When we have the course about Linux,
Yep.
we learn the basics of Bash.
Yeah.
And we use the site Regex 101.
Yeah.
For finding some regular expressions. But in Bash, syntaxes are different from Python.
Yeah.
About the regular expression. And this site will work with both of languages.
Yeah, I don't remember by default, like by heart. But I believe there are like some options that you can specify the language. So yeah, you can see that there is a different flavors. You can utilize Python and basically, yeah. So, and in reality, it's true that regular expression, the syntax can like be slightly different because yes, there are like as you see different flavors. And just like from my point of view, I even know that we have like regular expressions in Python, but also we have regular expressions in the R programming language. And there also it's like slightly different. For example, if you want to say that you have like a digit, you need like to put not just like one. I always like mistaking about slash backslash, but the idea is that you need like to put two of them somehow, and then it will be any digit. But this will not work as supposed in the R programming language. Here, yeah, it's like very nice that it like show you what each meta character means, and also like any quantifier that you have, so you can basically take a look there. Yeah, but yeah, so that's true that it's like can be slightly different, which is like annoying. I mean, I hate it that different implementations have like slightly different syntax, and sometimes it drives me crazy. But that's true.
Okay, thank you.
Yeah. And here, just as an example, that you can utilize you can use groups to replace things. And in this case, we have like, for example, some word, right? And then comma symbol, white space symbols, and then again word. And then you can use a pattern to replace things. Basically, if you want like to substitute something in your regular expression approach, you can utilize the sub function from the regular expression module. And here we put like a pattern, then what we want like to put as a replacement for this pattern, and then text. And here you can see that we took our pattern, and then we just like used we want like to put group 2 in the first place and group 1 in the second place. And you can see that we got like from Doe John, John Doe. We like just swapped them. And it's like very handy way to substitute, because sometimes you want like to, for example, just like in reality you can just like, for example, just like replace something by one group. Let's say that we want like just to keep the first group, and you can see, so we just like got the first group. Yeah. So this is an example of substitutions.
But it's replacement without the comma. How we can save the comma from original text?
You can also put it to the group. Yeah. For example, yeah. Or you can also put it in a separate group. I mean, like there are different ways, yeah. But just
Okay.
yeah. So I think that's it about the groups. Yeah, and basically, so what you need to do, it's like just like to memorize all these different nuances about the syntax that you need, that you want like to use. So just like simple groups is very simple. Then you have like named groups. So if you want to utilize them, just like you need like to memorize the syntax for that. Yeah, probably in my mind the second frequent thing, it's like about non-capturing groups, because sometimes you want like to specify something but not capture it to the groups. Yeah, back references is very useful, but this back references is like very simple. So you just like put like a backslash, and then you put like a number. So that's it. Yeah, and substitutions also very cool thing for regular expressions, which is like you can utilize the re.sub function. Yeah, and there also like a idea about look ahead and look behind in in the regular expressions. And let's just take a look on the examples. So I'll just show you. So here, if you want like to specify the positive look ahead, the syntax is that you need like to put like a question mark equal, and this is a what does it mean? So that we will match X only if it's followed by Y. Yeah, and then there are like examples. So here we have like a pattern which is like kind of as a word, and then we're saying that the word should be followed by car, and we are saying that this is a positive look ahead. That means that it's like supposed to be ahead of our word. And here you can see if we have a text red car, blue bike, green car, and now we want just to find the color of the car, but not for a bike. And then here we just like iterate through the matches of our result, and you can see so that we found that we had like a red in front of the car and also green in front of the car. Yeah, and then you can like also utilize the negative look ahead. That means that you can find anything which is not followed by the specified group, right? Not group, but kind of specified pattern. So in here we have like in the same way we have like word. Then we are like saying that there is like a white space, and then we don't want to have car. And because of that we found that there was a match for it, blue bike, and it matches blue. Yeah. Also there is a thing about look behind, which is like simply if you have something before your thing that you want like to match, you can use the following syntax. It's like a question mark and less or equal, right? Here it was like just equal, but yeah, less or equal. So syntax is not like very intuitive, right? You need like to memorize all these different things, but the best way is like always to practice, right? And then you will learn.
Yeah, it's need to practice only.
Yeah. Also, I know that there is a website which is like I'll try to find it, and it's very nice because it's like shows you as a just like tasks about regular expressions, and there it's like also explaining things, and then you can just like practice there because it's like says that, for example, this is a string, and you need like to find all occurrences of something, and you just need like to specify the pattern, and it also can be very useful. Yeah. But so this is just as an example, so that you can say that I want like to find something which is followed after the y. Yeah. Or like match x only if it's preceded by y. And this is an example that you want like to find digits, and there should be dollar symbol in front of them. And we put backslash because dollar symbol it's like some meta character, and we want like to use just like a dollar symbol as it is. And here is just like as an example that we found 100, 200, yeah. And then also we have like a negative look behind, which means that if we don't have something in front of the word, then we will match it. And in this case, we want like to avoid dollar symbol in front of the value. And for example, we had like items which is $5, $10, $15, $20. And then we will find just like 10, 20 by using this code. So this is a summary about look ahead, look behind. So you can always just like also another way is like just like to recall that there are some things which allow you to identify that I want like to have some pattern followed by some particular thing or not followed, then just like Google it or like open websites about the regular expressions. But I would like to show you some examples of the usage of regular expressions. So let's just copy and paste. This is an example of the extracting URLs from the text. Let's call it urls.py. And here is an example of our pattern. So we have a text, you can see, so this is a visit our website, there is a website or our sister site, we have like also another site. And here we have like a pattern, which is starts from the, as usual, right? So usually in the URL we have like a protocol, which is like HTTP, or more modern and secure, it's like HTTPS. And this is basically the protocol which is like specify how the like a client and the server gonna interact with each other. So as you can see, we put a question mark after S to say that it can be there or it can be absent. Then we have just like a regular thing from the URL, and here we have like a, so this symbol means or. We can have it, or we can have this part too. Basically, because some sites can start from 3 like W, some can like omit it. So you can see here we have like a URL which doesn't have like a 3W in front of the actual domain name. Yeah, then we have like a domain name, which is like can be anything, any like letters, any characters from A to Z in upper and lower case. Also it can be digits, and it can be a dash symbol, and also it can be dot. We can have dots. Then there is a top level domain, optional path, right? And let's just run it. So here is like we want to find all matches in the text. In this particular case, we use find all. But basically, so the idea is that the main thing it's like research, and then you can like just have more flexible things like by using find iter, and then it's like give you the iterable object where each element of this iterable object is like indeed match. Also, you can use find all. They're like very similar to each other. And here you can see that we have our match, right? So for matching matches. And then we have like a protocol or 3W. We just like got it from the match. And then we have like domain, TLD, path. Then we have like, we want just like to get the URL joined by the match. So match basically it's like you can think about it as a iterable object. We just get the full URL, and then we just like using the nice formatting to output the result. And so here you can see that the full URL was like this one, right? And then so the protocol or 3W is like HTTPS. Then the domain was, so basically this is a domain. And then the path that we identified, it was like the path to page. And for also we found like example.org. Yeah, and since we had like a optional argument here, so this is in the same way as in the logical algebra, it's like or. We found that we have like just 3W example dot. Sorry, it's like here. Yeah, but you can see that it's not like accompanied, or how it's like, it's not followed by HTTP or HTTPS, because we had like a or operator here. And yeah, so protocol or 3W, just simply 3W, domain is like example.net, .NET, and the path means that it's like a root path because we didn't specify some path inside of the page. So yeah, and this is about the URLs which you can try to use. So I'm not like saying that it's like guaranteed to work with any possible URL, but probably it's gonna help, like it's gonna work properly with like majority of them. But always you can, if you need to, fine tune it. There are also like example about the validating and masking credit card numbers. So you can just like take a look on it, that sometimes you have like credit card numbers in the text. You can also in the same way specify pattern and then like split it. And as I showed you with a kind of the social security number, here we masked the credit card number and we just like showing the last 4 digits out of it. Yeah, this is an example. So that's it for today. Yeah, if you have any questions, then yeah, feel free to ask.
I think now I don't have a question.
Okay, cool. Yeah.
It needs only practice.
Yeah. But I just like recommend you to practice with regular expressions because in reality it's very useful in many things, not just even in the Python. For example, if you're like working with directory structures in a Linux or on a Mac OS, it doesn't matter. Sometimes you want like to grab and find something by particular regular expression there, and this is nice to just like know how to do it.
Okay. Thank you for lecture.
Yeah, welcome. Yeah, bye.
Bye.